Hello Professor, today is my video about assignment 2. So first I upload my assignment 2 CSV file into the content folder and I name it that file name bằng the path contain assignment 2 and using pandas to read the file and name it iris and then using hit to bring first file out. So this is the result after import and bring first file out. And then I I replace the last column from the string to the integer number 0, 1, 2. So here iris.ilogs is location. So the column is present for the on round. The second is -1 is present for the last column. Is equal, replace the last column, center side by 0, etc. And then now I bring first file round again to check the result. And here we can see first file round is Sentosa, but now it's 50. And next is I apply X by using iris ilogs. Again, colon present for the on round, colon 4 present for the first 4 column, and we pick up on the data, apply to X. Same here, we have Y will be the data from the last column minus 1 location. Next one, I import the sklearn model selection, import train test slip. So I have xtrain, xtest, etrain, etest. We have slip 20%, the random stay 1 to 3 at request from the assignment. So next step, we bring each of them to validate the information. So I have xtrain.head, first file round for the xtrain. So xtest.head, first file round for the xtest. So I have etrain.head and etest.head, first file round. And then I can check the length of xtrain is 120 and the length of the test is 30. So meet the requirement. So next one I using to categorize to convert the etrain and etest from the number like 0, 1, 2 to the vector. So the number 3 is present because the iris dataset we have the 3 unit classic label 1, 2, 3. So that's why we set number class equal 3. So next one is I import sequence dense input categorize cross to define the model. So the model using the sequence of 3 layer, each layer, first layer 100 unit, second is 100 unit, and then last one is 3. Softmax activation using softmax because we ensure double sum is to 1. So next one we compile using RSM probe optimizer, loss is categorized cross metric is accurate, and then we train the model using fit export 20 party 10s. The validation based on xtest and one hot test label that we name above. So after train we can check the loss accuracy. We can check the average, the accurate of the is 0.8 and the loss is like about 21%. So the second one is the model 2. So same thing, 3 layer, first layer 10 now, second layer 10, and the last layer is the same. So we compile again, we fit them, we train the model, and now we check the accuracy is reduced. So now there are few questions for the assignment. So first, the more layer and hidden unit allow the model to learn complex patterns, but can lead overlifting. So when we do fewer layer or unit may cause underlifting, where the model does not capture enough pattern. Next one, do we always have suffer from overfitting? No, not really, because overfitting depends on the model complexity in the dataset. It occurs if the model is too complex for the data, or if the data is too small or noisy. And the third question, how can we detect overfitting? Like we can do using when the training accuracy increase, but the validation decrease. So this is when the overfitting. Number 4 is how can we reduce overfitting? We can reduce overfitting by using early stop training when the validation perform worse. Regularization, like drop or have to regularization a similar model. So when we change one of these using the model we have from number 9, so the result will be different. For example, optimizer. So we change up optimizer from the RSM proof to the Adam. So the accuracy will be different because Adam generate more faster and more efficient. And when we change the number of player, like we only use 2 here, so the accuracy will different because reduce layer can reduce the model capacity, which leads to underfitting if the model cannot capture enough patterns. We increase the hidden unit, so increase the number of hidden unit, the model capacity to learn will be increased, and thus we change the number of epochs. So above we have 20, now we only have 10 epochs. So increase the number of epochs allow the model to train more iteration over the data, which can lead to higher accuracy. And the last one, we change the batch size. So the batch size above is 10, now it's 20. So the last batch size means fewer updates per epoch, but each update is based on more symbol, which could lead to more stable training. Thanks for listening.